I'm Ray Rodgers. I'm the chair of geology at Macalester College, and I'm here to introduce my department's virtual video tour. And you know why this has to be. You can't visit us this spring, and so we put this little tour together so we could visit you via the internet. So for the next few minutes, sit back and you'll learn a little bit about the geology department. Real quick, behind me, you see a lineup of my colleagues on the main floor of the geology department. So that's the main floor, bottom floor, Olin Rice Science Center. And you'll meet several of these people in the next few minutes. But first, before the tour begins, let me congratulate you on your recent acceptance to Macalester College. If you have any questions about the college or the geology department, please email me, and here is my email address, rodgers@macalester.edu. I also encourage you to check out the geology website right here. The website's been recently updated, and on it you'll find lots of information about courses, all the courses that we teach. And you'll also learn what our students do with regard to research, their theses, projects they've completed, and importantly, you can also learn what our students do after they graduate from Macalester, and they do great things. So check out the webpage, and I think a lot of your questions will be answered. Now, before I introduce my colleagues, I'm just going to take a few moments, maybe a minute, just check my timer, and I'll let you know briefly what I work on. I'm a sedimentary geologist and a paleontologist. I'm very interested in the process of fossilization. I study it mostly in relation to dinosaur fossils. And so I've worked with my students over the years on fossils from Madagascar, Montana, many other places to understand how fossilization occurs. And we work in the lab, we work in the field. And if you want to get a feel for this type of research, visit my webpage. There's lots of theses, lots of published papers, and you can dig more deeply into it if you so desire. And like I said, if you've got any questions about geology or my research, dinosaur fossilization, hit me with an email and I'll answer your questions. So without further delay, let me again say congratulations. We hope to meet you next fall here on campus at Macalester. And for the next few minutes, you're going to meet some of my geology colleagues. So take care, stay healthy. I hope to meet you soon.
Hey everyone, my name is Kristi Rodgers, and I am a professor in the geology department at Macalester. First of all, congratulations on your admission to Macalester. Like me, you're probably social distancing, so I'm coming to you live from my front porch instead of from my research lab. But I wanted to give you just a little taste of what the geology department is all about at Mac. I am a dinosaur paleontologist, and that means that my classes and my research all surround questions of the evolution of life on Earth. I teach a class called Dinosaurs here in the geology department. That class is an amazing class to teach. I get to teach students from all across campus. We have an amazing end of the semester party called the Dinosaurs Extravaganza, where we celebrate a semester-long project that students complete, and it is a total blast. You can check it out on the website. We have some footage from last year's extravaganza up right now. I also get to teach classes on vertebrate evolution, so how backboned animal life on Earth has evolved and changed over time. And it's really cool to be a professor teaching classes like that because my research mirrors that teaching that I get to do. And so my work is mostly focused on how dinosaurs grow, how they evolve, how their anatomy can tell us something about what they were like when they were alive. I also really love being a part of the geology department. It is one of the most tightly knit communities on campus, and that extends from the students to the faculty and interweaves that group of us together really tightly. I always find a lot of inspiration both in my faculty colleagues in the department, but also in the students that I teach. I hope that you might consider becoming a part of our geology community in fall 2020. And if you have questions between now and then and you'd like to learn a little bit more about what I do or have questions about the department in general, just email me. You can hit me up at this email address, rodgersk@macalester.edu. And until then, stay safe, stay healthy, and take care of each other. Hope to meet you in the fall semester.
Hi, my name's Alan. I study how the edges of continents form. In order to do so, I visit places like the Western US and Western South America, collect rocks like this, liberate the minerals that are present within them, and then date those minerals. Let me take you on a quick tour of how that whole thing works. Step 1, take your favorite rock, put it in this thing, chomp, 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 choose it up into little bits, take those little bits, put them into this thing, rotating disc mills it up into a sand. Then you're left with this bag of sand. Take that bag of sand, bring it over to here. Fancy table, basically like panning gold. Step 2, take what comes off the gold panning table, put it through this really powerful magnet, take the non-magnetic stuff that comes out the other end of that magnet, bring it over here, put it through some high density liquids. They have a density 3 times that of water, and then hopefully what comes out the other side is the mineral zircon, which we can date using uranium and lead isotopes measured in a mass spectrometer, which tells us about the timing and speed of plate tectonic processes. Thanks for coming on this mini tour, and I look forward to hopefully meeting you this fall.
Hi there, my name is Kelly McGregor. I'm a geology professor at McAllister College in St. Paul, Minnesota. I'm recording this video because none of you can be here to visit McAllister because of the COVID-19 pandemic. But I wish you were here, but you're doing the right thing by staying home. As a member of the geology department, I get to do lots of really cool research with students. My training is as a glacial geomorphologist, which means that I get to go out into the wild and study glaciers. And I love what I do. I actually just made it back a few days ago from doing fieldwork on the southern Patagonian ice sheet in Argentina. I also do fieldwork in Glacier National Park in Montana, and have also spent a lot of time working in Alaska and British Columbia on glaciers in those areas. In addition to my work on glaciers, I also work on river systems in some collaborative projects with ecologists looking at the impacts of sediment transport on native river mussel populations. So I do lots of great work. I love my department. I love McAllister. It's fantastic to have a small liberal arts college located in a really cool urban environment. In all of my classes that I teach, I bring students into the field. We do overnight field trips, camping, hiking, looking at the environment around us. I also spend time taking students to laboratories at the University of Minnesota and other nearby colleges, working with collaborators there. I really enjoy what I do. I think McAllister is a fantastic place. I feel very lucky to be here. And I hope I get to meet you in the fall of 2020. If you have any questions about the geology department, the research I do, or McAllister in general, you can go to my webpage, but you can also email me directly at mcgregor@macallister.edu. I look forward to seeing you in the fall, and congratulations on your acceptance to McAllister. Bye.
Hi, I'm Jeff Thal, and I'm the lab supervisor in geology here at McAllister College. I teach the lab sections of our intro courses, Dynamic Earth and Global Change, and History and Evolution of the Earth. I'm also in charge of the Keck Lab, and I'd like to give you a quick tour to see some of the instruments that our students use for class projects and when conducting faculty-student collaborative research. First, though, let me congratulate you on your admittance to McAllister. It's an exciting time. I know both my children stood in your shoes not too long ago, but I'm sorry you can't make it to campus now or in the near future due to the current crisis. But we're hoping that the information we present will help you in your decision-making process. So let me give you a tour and show you some of the amazing instruments that we have in the lab. The first instrument on our Keck Lab tour is the Scanning Electron Microscope. It is probably the most widely used instrument within the Keck Lab, and it's used to look at a variety of different substrates for a number of different types of investigations. It has both energy dispersive and wavelength dispersive spectrometers on it, and a number of different imaging modes. Some of the things we've looked at in the past include pollen. You can see that round feature there. There's a thin section of a metamorphic rock to the right of that. That's a large garnet. Below that is a deer tick. Next to that is what we call an igloo, which was actually a growth inside a bivalve within the Cretaceous interior seaway of Montana, and it represents the existence of a parasite, some of the earliest known parasitism that we know about. On the left, the large image are some well-formed apatite crystals within void space within a dinosaur bone from Madagascar. On the right, we can actually see the analysis of those crystals from our energy dispersive spectrometer, And it shows us that those crystals are a mineral called apatite. So the next instrument on our quick tour of the Keck lab is the Xray Diffractometer. I apologize, it's a little loud in here due to the presence of the chiller, but I'm going to click start here and get the instrument running. And the way this instrument works is it's using X-rays to bombard a sample, and if it's a crystalline material, it'll produce a diffraction pattern. The diffraction pattern, once we collect it, we can then analyze on another piece of software that we compare to a database, and it should allow us to identify whatever mineral or minerals were present in that particular substance. The latest addition to the Keck lab is the Bruker M4 Tornado Micro XRF Xray Spectrometer. This technology uses a high precision stage to pass a sample underneath a focused 20 micron X-ray beam that allows us to measure the distribution of elements within a sample with high precision. This particular sample shows the distribution of manganese and calcium within a manganese nodule collected from the ocean floor. Pretty spectacular image. So just to wrap up, that was a quick tour of some of the instruments in the Keck lab that you as students would be able to use if you were a student here at Macalester. We have additional equipment in there. There's an atomic force microscope, there's a gamma ray spectrometer. Our geology program has all of the traditional tools that geologists use. We have saws to cut rocks, we have polishing equipment, we have equipment to make thin sections, we have microscopes in all of the classrooms. Anything that a traditional geology program would have. In fact, I'm sitting in one of the classrooms. If you happen to be a student here, this would be one of the rooms that you would take classes in within our program. But again, congratulations. I know you have a difficult decision ahead of you. If you have any questions, you can reach out. I'm on the web. You can contact me through my phone or my email. And I hope to see you next fall. Stay safe, stay healthy, and we'll hopefully see you soon. Bye.